Hello, welcome back to Mr. Weed and Maths. We're on to the next video now, which is about division of indices and what happens and the division law. So I have here a division. Now remember, a fraction in mathematics is the same as a division. I have 3 to the power of 5 divided by 3 to the power of 2. Now what I'm going to do is use the thing from the previous video. I'm going to explain what this means. Now this is a 3 multiplied by 3 multiplied by 3 multiplied by 3, and finally multiplied by 3. Lovely. And then I've only got 2 3's on the denominator. Now what we can do in mathematics when there's multiplication on the numerator and denominator, we can do some cancelling. So this 3 cancels with this 3. I mean, it can cancel with any of them, but I've chosen to cancel it on the end. And then this 3 cancels with this 3. So we are left with 3 3's. So we got 3 to the power of 3. Now I'm hoping you already know what you could do here. When we had multiplication, we are adding the powers. And when we are doing division, we are going to take away the powers. That's the trick we can do. We don't want to write this down every single time. That's going to take us forever. We want a nice rule we can use. And that's what we can do here. When the base numbers are the same, we can take away the powers. So let's show you a few more examples. This time I have 4 to the power of 9 divided by 4 to the power of 5. On this one, I've got a power of 9, I've got a power of 5, I take it away. So I would end up with my base number won't change, and then a power of 4. That's it. Next one, let's write it as a classical division. I've got x to the power of 12 divided by x to the power of 3. Okay, here, even though it's not written as a fraction, it is still a division. So we are going to do this value, take away this value. And we would get x to the power of 9. Okay, couple more. We are going to do 5 to the power of 7 divided by a 5. We saw this in the previous video. When you have a singular value, the invisible power is 1 because there's just one of that value. So we've got 7 take away 1. So my answer over here would be 5 to the power of 6. And then my 2 more examples. I've got y to the power of 7 divided by y to the power of 5. No. Change that. 9. I wanted to show you here. So here you can end up with negatives. So I've got a 7. And I've got take away 9. And it's absolutely fine. You haven't done anything wrong if you end up with a negative number, not necessarily. 7 take away 9 would be negative 2. All right, the last one I wanted to show you, I'm going to rub everything out that we've done so far. The last one is a little trick that can occur. And it's about the knowledge of your negative numbers here. So the trick that can occur is this one. If I have x to the power of 4 divided by x to the power of negative 2. So you have a negative on the denominator, or you're dividing by a negative power. What you've got to think is what this rule tells us. When it's a division and the base numbers are the same, we take away the power. So this would be the same as x to the power of 4 take away negative 2. And I'm hoping you all remember when you take away a negative, it's the same as adding. So this is an add. It's 4 plus 2. And so that will become a 6. So just be really careful and don't get caught out when it's a division and there's a negative power there. That's where I've seen students make mistakes before. Don't be one of them. Get practicing. Bye.